In chapter 2.2, we'll see information about linear relations and functions. And so here are some of the definitions that you're going to be using. So what is a linear relation? Well, look at this here. It says linear, linea, so line. So a relation whose graph is going to be a straight line. And then we have non-linear relationships. So a relation that is not a line, it would be considered non-linear. A linear equation are where you have variables to the first power and operations like multiply, add, subtract, that kind of thing. So linear equation is always to the first power. So you'll see usually it'll be the letter x and it'll be to the first power. If you have a linear function where you have x's and y's paired up together, the ordered pairs that satisfy a linear equation can be written in this form. Like I showed you in the previous demonstrations, you have the f of x, so that automatically tells you have a function, is mx plus b. So m is the slope, and another word for slope is rate of change, and b is the y-intercept. So in the initial value, usually where you start drawing your graph. So in standard form, they give you the equation that looks like this. They put the x first with a coefficient, so it's some a times the x plus b times the y is equal to some constant, just a number out here. So a and b are not zeros because then it would cancel that, right? So to find equations, we're going to practice from taking it from standard form and putting it in what we're used to make it look like this as a function, and we'll be talking about that in the examples. So two important characteristics of an equation is you most of the time will have some kind of y-intercept and an x-intercept. Now, to find these, you just need to find where the opposite is zero, right? So to find the y-intercept, in other words, where does it cross the y, you're going to see that at that point, the x value, so x is 0, y is whatever number, let's say it went up 5 or 6 or 7, whatever. To find the x-intercept, so where does it cross the x, the y has to be 0 because you don't go up anywhere. You just go over here to the x value and the y is 0. So a quick little trick is turn the opposite letter into 0 and that'll tell you where the intercepts are. So we'll be looking at that in the examples. All right, so now looking at the packet, we've got chapter 2.2, linear relations and functions. And so here are the key vocabulary words which are in the notes, and you'll see some examples here. So let's go ahead and some of these have an explanation, so I'm going to go over the ones that do not have an explanation. So it says state whether f of x is equal to x squared minus 4 is a linear function. Well, automatically I see a problem. I see x squared, square. So square is not linear, it has to be to the first power. So no, it has an exponent other than 1. So make sure that your linear equations do have a power of 1. And so there's some more key ideas and so on. So in the standard form of a linear equation, which you have that ax plus by equals to c, don't worry if they do give you an equation like that, we could always fix it. So let me go ahead and try looking. There'll probably be some examples. So just to read that note about the standard form of a linear equation, which they can give it to you in this manner right here. And we could always turn it into the slope-intercept form that you're going to see later on. All right, so then how to find intercepts. Remember what I mentioned to find the intercepts. You set the x is equal to 0 or the y equal to 0, so you can find the opposite ones, right? So here, if you notice, they did that. They made the y equal to 0, so they solved for x, and so x equals 2, negative 2. So one of your intercepts, the y-intercept, I'm sorry, they were looking for the x-intercept here. So you've made the y equal 0, so you find that the x-intercept is negative 2, 0. So now you have a point that you can put on the graph. The same thing if you turn your x into 0, and so if we had plugged in a 0 here, solve for y, then you could have gotten what the y intercept also equals to. Notice how they have here the original equation, and they want you to put it in standard form. So all you need to do is move your x over to the right hand side. So it was positive here, becomes negative on this side. plus y is equal to -9. And then it's almost done. I just need to get rid of that negative. So they multiplied both sides by -1, and that will take care of it. So moving from one form to the other is pretty simple. We'll do some examples also as we go along. And so here you have more explanation of the intercepts and how to find them. All right, so in your study guide and intervention part of the packet, you'll see some questions that you can work on that will help you solve some of these questions with having to do with functions and so on and so forth. So first of all, state whether the function is a linear function. All right, so let's just start with any random question. So let's say something like number 9. Is that a function? Well, automatically I notice that you've got two variables being multiplied at the same time here. So I would say no. Remember, our variable should be to the first power, but not like with each other like that as that example. So no, and so on. I already see a problem with number 7. 7 has x to the third power. You already said that it should be to the first power. Some more examples. When you go to the study guide and intervention part, it says write the equation in standard form. So let's practice with any one of these. I had already mentioned that sometimes the equations will look like this or without a number here in front of the y. So let's go ahead and try to fix this one to make it look like standard form. So let me just go back to the problem. And so remember we said standard form looks like this: ax plus by equals to c. So in other words, you have the x first, then the y, then whatever number. Well, I see that the 3x is already in the wrong spot, so it has to move this way. So I make it -3x since it crosses the equal sign. You make it a different sign. And then plus 2y is equal to 6. Now I'm getting closer. The problem is I've got a -1 out there. All you have to do is just multiply the whole thing, or the left and the right side, by -1. As long as whatever you do to the left, you're doing to the right, you're good. So -1, negative times negative becomes positive 3x. Negative times positive becomes -2y, and that will equal to negative times positive is -6. This is your equation in standard form. Now it says to find the x and the y intercepts to graph these. So remember the trick. The trick is you turn each of these into a 0. So let's say I turn the x into 0. Let me make a note of that. So when x is 0, the y is going to be, well, let's see. So 2 times 0, this cancels out. So I just have to solve for that. Divide by 7, both sides. So y is equal to 2. So when x is 0, y is 2. That's one of my intercepts. And so now let's look at finding the other one. So now, since I already found the y-intercept, let's try to find the x. Remember, to find the x-intercept, the y is 0. So I make y 0. So 7 times 0 cancels out. So now this would just be a matter divided by 2. So x is equal to 7. So if you notice, they extended this arm here. So 1, 2, 3, 4, 5, 6, 7. So about right there. So it's probably easier on your paper than me using the pen on the computer to show you that, but that's kind of what your graph is going to look like. Hopefully your line is a little bit nicer than mine. It should be a straight line, but that is how you would do those graphs there.